SOLIDWORKS Simulation 2022 now has a lot of really cool performance enhancements. My favorites are the new linkage rod connector, so we can go ahead and actually simplify our geometry even further, and the ability to coarsen the mesh with mesh controls, right? That's something new this year, which the developers have worked in, which is really, really nice. So rather than applying a super coarse global mesh and refining it with mesh controls, what we can do instead is apply a finer global mesh and actually coarsen it, pull the mesh back on components that we're not super interested in. A couple years ago, they added the ability to model both high quality and draft quality elements at the same time. And with this new enhancement, with the mesh control, it's going to be even nicer, right? So now we have super, super granular control over our mesh, and we can pull out all of the different things that we're looking for in the simulation. So the performance improvements, the productivity improvements in Sim are going to be really, really nice for 2022. Let's take a look at Flow, which is one of my favorite products.
SOLIDWORKS Flow Simulation 2022 offers some exciting new plots and the ability to analyze results across different projects. We are currently testing a new high-powered LED lamp for the Nemo submersible. This new lamp can run at 3 different brightness levels, giving users more options for different underwater environments. There's also a mixed power setting that will allow each of these 3 pairs of LEDs to run at either 2, 3, or 4 watts. Our mission is to determine which of these configurations operates at the lowest overall temperature. Running a transient analysis while switching the lamp through the different power settings gives us valuable information about how the lamp will cool down and heat up based on the external water temperature. The Transient Explorer is a powerful tool that allows us to visualize results run through a transient study. SOLIDWORKS Flow Simulation 2022 can now display the flux plot in the Transient Explorer, allowing us to get in-depth numerical results on how power is moving through this complex system. We can also now create new equation goals after running the analysis that can process values of other goals that have been declared beforehand. Let's create a quick equation goal that will compute the maximum temperature of all of the LEDs over the entire transient analysis. We've also ran several steady-state studies in a new experimental power mode where each LED in the lamp can be set to a different power setting. These experiments can determine if there are optimal configurations that maximize brightness and minimize heat at the circuit board. Comparing results between projects is necessary to understand similarities and differences, but simply putting 2 plots side by side is not always helpful. A new merge option allows us to collect multiple results and highlight the overall maximum and minimum values between projects in one combined plot. The new difference plot allows us to create a plot that displays the differences from one project to a reference project. These new compare plot options help us gain a ton of insight into the effects of the experimental power modes. There's also a new results summary that tabulates analysis data, providing a high-level overview across multiple projects. The scene plot has also been updated to store model orientation, zoom, and part visibility. So creating that perfect scene will also retain the display settings to view it perfectly every time, regardless of your current view state. We may want to add some probes to this scene to highlight locations of interest. Now, when we copy a scene or plot from one project to another, the probes are copied as well. SOLIDWORKS Flow Simulation 2022 keeps you in control of your results by providing a powerful new plot type and expanded flexibility to review and share results from multiple projects.
All right, guys, so just like structural sim, right? Just like SOLIDWORKS Sim, Flow, again, with performance improvements, mostly productivity this time, but we have a lot of really cool ones. My favorites being that difference plot. I can see that if we're running multiple projects and we have kind of a known configuration and we're testing some experimental stuff, creating those difference plots very quickly gives us a really good visualization into how different these results actually are. In terms of the equation goals, that's something I've been asking for a long time, right? If we know all of that data, we can now use it to do some calculations with it rather than pulling all that data into Excel and kind of creating our equation goals manually. Who wants to do that? We can actually go ahead and do it right in FlowSim, and it'll pull that data instantaneously because it has all that data in the background. It just has to do some addition, subtraction, and different operations for us. So that's super, super nice. Having the flux plot be available in a Transient Explorer is also really cool. I love the flux plot that was added a couple years ago because it's a visual representation of the energy balance in our system, right? If we have, 400 watts in, we need to have 400 watts out somewhere. Otherwise, the first law of thermodynamics is being violated somehow. So we need to know, it's a good convergence check or a sanity check on our system, especially if we're designing things like heat sinks or thermal performance where it matters where every single watt goes, right? Every single temperature, every single degree temperature rise makes a big difference in terms of our performance. So being able to visualize that across a transient study is a really, really nice new feature this year. The last desktop product that I cover is SOLIDWORKS Plastics. So what we can do is take a look at some of the improvements again in SOLIDWORKS Plastics.
SOLIDWORKS Plastics 2022 adds features and horsepower to solve more complex problems with greater ease. This plastic cover is bolted to 2 hoist hooks on either side of the hatch. Since it has an asymmetric design, both a right and left-handed version are required for the Nemo submarine. We'll start by adding a material for the plastic injection analysis. The material database is key to any plastic simulation, and this year we've added over 100 new material models and updated over 1,500 existing materials to improve fill, pack, and warp accuracy. For this part, we'll choose a Delrin resin. The new Injection Location Advisor gives immediate feedback on where to place the injection point. It even automatically solves for the optimum pull direction based on your geometry. But for this model, we've decided to go with a sketch-based runner. Using the updated and simplified runner tool, just click the sketch segment and choose the dimensions. The new Flip Dimension button makes it even easier to build your custom runner. And now, there's no need to define the number of elements for each segment. It's computed automatically in the background. We need a family mold to create cavities for both the right and left-handed components. In SOLIDWORKS Plastics 2022, we can use the new symmetry boundary condition. This will create a virtual opposite-handed cavity in one easy step. Simply click on a plane that cuts through the sprue, and the new cavity and associated runner is created. But what if you need a family mold with multiple cavities of the same part? The new cyclic boundary condition allows you to create additional virtual cavities in a circular pattern. Just click the center of the sprue sketch line, the number of cavities you want, and you're done. And of course, if you choose to model your runner system using solid geometry, both the symmetry and cyclic boundary conditions can also be used. When it comes time to solve the analysis, the new Run button is only a right click away from the top of the tree. And when analyzing your fill, pack, cool, and warp studies, turning on the symmetry option allows you to visualize the full virtual cavity. SOLIDWORKS Plastics 2022 combines additional functionality, simpler pre-processing, and powerful automation to get accurate plastic injection simulation results faster.
All right, guys. So plastics, again, is not something that we see all that often, but it is a very, very powerful design tool. It can help us take a look at things like injection locations, injection pressures, make sure our parts are going to fill correctly the first time, all of that good stuff. You don't need me to tell you that. But what we're here for is the improvements in 2022. And they finally closed the loop on the plastics update project they started a couple releases ago, where now everything looks and feels a lot more like SOLIDWORKS Simulation, which is what a lot of you guys are using. So it's an easy transition to go from sim to plastics. And we can import our plastic stresses back into sim to take a look at things like residual stresses, in-mold stresses. Everything works together in the SOLIDWORKS family of products, which is really, really cool. That's all we have for desktop, but there are improvements to the simulation aspect of the 3D Experience platform as well. So as a quick refresher, if you guys were here last week, you saw Jesse's 3DX in 3 minutes video. if you were not here, we get to watch it again. So I'm just going to let Jesse take away and introduce the 3D Experience platform as a whole, and then I'll come back and introduce the improvements to the simulation side of things.
When you test your
By now, you've undoubtedly heard about the 3D Experience platform. But what is it? Is it just SOLIDWORKS on the cloud, or some new product altogether from Dassault Systems? In this video, we'll explain what it is, why it exists, and give an overview of how the system works. My favorite explanation of the platform is a single source of truth for your organization. I think that phrase really encompasses the benefits that the system provides. The platform simply provides you with your own private and secure section of the cloud. It's a space where you can store your files in an accessible area and communicate design information and work directly within your web browser. Think about your organization for a moment. Whether your organization is large or small, chances are this will apply. Does everyone in the organization have access to the information that they need, and only the information that they need, at all times? I'm going to wager a guess and say no. In fact, that's less of a guess and more of an observation from what we've seen in the past 3 decades of being in business. It's very difficult to get every member of your team access to the information that they need when they need it. And that's where the platform really shines. All of your information is in one place, that single source of truth, and in your control as to who has access and what information and which tools they need to make use of it. The platform itself is simply a backbone for tools to build upon. It provides an environment in which your tools can operate. The platform can be customized with tools that are specific to your needs rather than delivered as a complete system. Here's how it works. When you purchase licenses, you're granted access to what's called a tenant. This is your private space on the cloud. You can choose who has access to the information available on your tenant. Access is provided by obtaining licenses that are called roles. A role is just a preset package of applications that's designed to meet a specific purpose. Roles are analogous to the way that software is currently delivered today. For example, you might get a seat of SOLIDWORKS and Simulation for an engineer, and Composer and Visualize for a member of the marketing team. In the same way, you would obtain the applicable roles for each member of your team. This provides them with the access to the information that they need, as well as the necessary tools to interact with it based upon their daily tasks. You'll find that this site is organized based on these levels. The number of roles available is extensive and ever growing, so to help you navigate these tools, we've broken them down into categories. Simply browse each category for the related roles. Each role will provide you with the information and the key applications that come along with the role and the benefits that it provides.
All right, so just as an aside, right, just as Jesse was saying, just like it's very analogous to core desktop SolidWorks, right? If we need modeling work, we go to SolidWorks. If we need analysis work, we can go to Sim, Flow, Plastics, just like we saw, right? With the 3D Experience platform, it's the same thing, right? If we need modeling work, we can either stay in SolidWorks and simply connect our data management to the cloud, or we could model on the cloud, right? We can design right in a web browser. If we wanted simulation work, that's where I come in, right? We can talk about Sim, Flow, and Plastics on the cloud. There are roles available for all 3 of them. They are very similar to the desktop roles for Flow and Plastic. And for Sim on the cloud, we can actually go above and beyond what we can do even in SOLIDWORKS Simulation Premium, which is what we're going to see in this next video, because that's where they made major improvements this year. So let's take a look at the structural role or the structural suite of products on the 3D Experience platform.
Products virtually or in the real world. Naturally, you're exploring numerous design options, evaluating how long they will last, and finding out when and where ultimate failure may occur. And it's no easy task. When simulating numerous physics and loading scenarios, collecting and making sense of all of the data can be daunting and time-consuming. This is especially the case when the design and analysis tools are disconnected or limited, but there is a better way. The 3D Experience platform provides a collection of best-in-class simulation apps built with industry-leading technology, including Abacus and FE Safe, and connects seamlessly with SOLIDWORKS. Adam the Analyst is working on the Nemo submarine to help satisfy their safety and certification requirements. When it comes to the battery compartment and skid, he has a few remaining tasks. With a depth rating of 100 meters, it is critical that the battery compartment can withstand the pressures beyond that depth to ensure safe operation, but at the same time, weight and cost must be reduced wherever possible. Adam considers the thickness of the steel tube and stiffeners and defines the associated dimension as parameters to be optimized. He saves our updated model to the platform and launches the Model Assembly Design app to start the simulation process. First, a mesh is created. The automated FEM recognizes the thin components of the model and creates mid-surfaces and associated shell mesh bodies all in one command. Next, Adam creates the structural scenario that defines the load and boundary conditions to simulate the maximum design depth rating. At first glance at the results, it is obvious that the structure is over-designed. Adam launches the Parametric Design Study app, selects the parameters and goals of interest, and lets the computer do the rest of the work. When the study is done, Adam can easily interpret and compare the performance of the various configurations. The best design is even highlighted for him. With one click, a new model and study using the optimal parameters is created so Adam can take a closer look, but he has additional tasks to complete first. The pressure load on the battery compartment happens multiple times throughout the life of the Nemo. Another loading condition that repeats is the impact of the skid landing during storage. To simulate the secondary loading condition, Adam creates an explicit dynamic study to accurately capture the rapidly changing stress from the landing cycle. How exactly does the skid come into contact with the floor? Adam lets the solver figure that out with one simple yet powerful general contact interaction. To greatly decrease the solve time, Adam chooses to run the simulation on the cloud, leveraging high-performance computer power. Adam can even shut down his computer while the simulation runs in the background. The stress values are within our expected range, but how many times can the Nemo withstand both this and the pressure load? To reveal the answer, Adam sets up a durability study. He defines a fatigue loading that captures both events. For the explicit dynamics results, he includes all increments to account for fluctuations in the response. Adam also includes both stress and strain in the calculation to improve the accuracy and solve for both high and low cycle fatigue. Both sequences occur in the loading history, but they are exclusive events, so he turns off the inter-event transition option. Lastly, he defines the base surface finish and solves for the results. These results are not only available to Adam, but they may be also viewed by other collaborators from their internet browser, so everyone can get the latest information instantly from one place. Adam's last task is to identify when and where ultimate failure may occur if the Nemo gets too deep. Leveraging the same study setup from the first scenario, he defines a Rick's buckling step, which goes further than the typical eigenvalue buckling analysis and is well suited for an unstable and nonlinear collapse of a structure, and it doesn't require setting up a more complex dynamic analysis. Processing the results is simple too. Adam plots the load factor and visualizes which areas of the compartment will fail first. By using the 3D Experience platform to explore numerous design options, evaluate durability, and understand critical loading events, Adam and his team were able to make informed, timely decisions to help fulfill their safety and certification requirements.
All right, guys, really, really cool stuff available on the 3D Experience platform. A lot of that stuff we can't do or it'd be very, very difficult to do in SOLIDWORKS Desktop. So it's definitely something to consider, especially if we're dealing with high energy impact events like that crash test on the bottom of the seafloor. That is some really, really cool stuff. There is, if you guys want the full list of what's new in SOLIDWORKS, not just simulation, but what's new in the entire SOLIDWORKS suite of products, there is a handout available in the chat. Which covers everything, right? Everything that we've covered last week with Charity and Sarah and Brian and Steve. and everything that I've just covered, right? All of the stuff available in the entire SolidWorks suite of products. Definitely download it, check it out, see what you think, and definitely let us know. If you have any questions, feel free to reach out to us. It is lunchtime exactly, so thank you for bearing with us through the technical difficulties. But again, if you have any questions, feel free to reach out to me, reach out to any of us here at CAD Dimensions. We're here to help you, and I hope you guys enjoy your lunch. Thanks for tuning in.